All right, all right. How's everyone doing tonight? Somebody can just let me know if I'm coming through correctly and you're seeing my screen when you get a chance. Um, and then we'll get going in just a minute. Close a few of these guys. All right. So I hope you guys like this idea. What I've found seems to be pretty effective because it's hard for you to ask questions when we're doing the remote for everyone is just working through a problem. And this is another chance to see all these different steps. Hopefully they click a little more seeing it work through. So I'm going to tackle this one from scratch without even having a Git repository yet. And we'll just sort of build up a solution to it. I don't know if it'll take that long. Hopefully it's, less than an hour, but it should be a nice example of practical hands-on working through something again. Once again, showing all those little bits that sort of matter. So go ahead and get started pretty much right away tonight. You can always ask questions. I have my other screen up as well for that. But first thing I'm going to want to do is I'm going to create a new Git repository for this. And I could create it inside of GitHub. It doesn't make a difference if I start there or if I start locally. So just to show a different pattern than we typically work, I'll go ahead and create one on my local system. This would be the same thing if you were doing it in Cloud9. Let me make this just a little bigger. Let's see where I am. I don't want to be inside of that folder. I'll just be in Code the Dream. And so what I'm going to do here to create a repository locally with Git, or if you're in Cloud9, a separate one, is I'm just going to git init. Oh, I want to create the folder first. So I'm going to make a directory, correct change, and then I'm going to go into that directory, and then I'm going to git init inside of there. And so now I've got an empty repository in this correct change folder, nothing in it yet. Why do we get S? Sure enough, we don't see anything. So now that I've got my repository, but there's nothing in it, I'm going to go ahead and start working in it. So one of the first things I'll do here, minimize that, like this. And all right, that's that. I'm going to change this one. Instead of being that folder, I'm just going to go ahead and open up this correct change folder here in whatever my browser or my dev tool is. If you're in Cloud9, you can just move into that folder. It doesn't really matter. And then to get started, I guess, I'm going to go ahead and copy over the markup or markdown here for this problem. And I'm just going to go ahead and, I'm going to give myself a little more space here. Reset my zoom. And then I'm just going to create a README markdown file and put that in there. So I've got some sort of stuff going on here. Now I can go back over to my command prompt and I can look git status. Sure enough, there's my README. So I'm going to go ahead and commit that. So I'm going to git add the README. Now, if I do a git status, you can see it's no longer in the untracked section. It's in the staged section. So now I can git commit and give it a message. I'll just do an inline message, initial README. Pretty basic so far. And if let me clear to bring stuff back to the top. If I git log, we can see my one commit in there. And git status shows that that file's no longer sitting there. So now I've got my repository started, but I started it blank, unlike last time. So I need to I need to connect it somehow to GitHub, so I'm going to be able to upload it. So up here, I'm going to go ahead and say, I don't know what import repository does. Let me see. Oh, that's not what I want to do. So I'm going to do a new repository here. And I'm just going to call it correct change. It's public, and I'm not going to initialize it with anything. And that's so that I'll be able to easily connect it to my existing one. Because when I click that, it'll give me this nice message. All right, so here's what I need to do now. It's really simple. I just run a couple commands from inside my existing repository. This first one just adds the GitHub as a remote Git. So once I've done that, now it's connected to GitHub, and then I just need to push to the origin, which is what we called the GitHub thing, my master branch. So I go back, push my, oops. Let me try that again. I need to put the permissions in. All right. And now if we look, we've got a basic GitHub project, and it's hooked up, so we can push stuff up to it, which is great. All right, so I know what I want to solve here, this correct change bit of code, right? But what I said is I'm going to do test-driven development, and I'm going to use Jest first. So I also know that I need a npm or a package JSON file, and I need to install Jest to it. So going back to my folder here that I'm in, I can do an npm init to create my package JSON, and correct changes fine. The version can be 1. I don't need a description. I'll call the entry point index.js. That's fine. Test commands. I won't put anything. Well, I won't put anything in for now. We'll edit it in a moment. That's the Git repository. No keywords. Author, I can put an author in here. Doesn't matter. And then license, I don't really care. I usually just do my T or something. Okay. So now we've got another change. We created an initial package JSON. Now, being the very cautious person I am, you'll see me go ahead and add that. Get status, we can see it, and then commit that as well. And then I'm going to git push that as well. If you're wondering why I get this prompt when I'm doing git pushes and stuff, it's because I'm using SSH. So it prompts me for the key for my SSH, or the password for my SSH file. If you're using HTTPS, it'll prompt you for your username and password. If you're using SSH and you didn't put a key on your SSH file, then it won't prompt you. All right, so again, git log, we see our 2 commits. Everything's good. So now the next thing I want to do, because I want to start writing my tests before I'm even writing my code, let's make sure, all right, looks good. I'm going to do this npm install. Now, some of you, I'll point out, some of you looked at this yarn command and were trying to run it, or say in the npm documentation you were trying to run yarn commands. That's an alternative tool to npm, an alternative package manager tool. So whenever you see yarn, you can almost always swap in this npm style syntax instead. We just happen to be using the npm tool. It's probably the more popular one for now, so it makes sense. Plus, it comes installed with Node, so we don't have to install something else. All right, so I know I want to go ahead and install Jest. Jump back over here, run my command. And it looks like it's taken a little while to go ahead and fetch everything here. We're getting all these bits of jest installed now. All right. I can clear, and if I do a git status, what you'll see is I've got a couple things listed here. I've got node modules and package lock.json. And my package file is modified. And none of these are listed as staged. This one say changes not staged, and these are untracked. Well, you remember we don't want to check node modules in. So now I need to go and add another file. This is one of the reasons I did this manually this time, is just to get some practice with this. Oh, look, my tool is literally trying to help me here. Would I like to add node modules to .gitignore? Yes, but I'm going to do it by hand. I'm going to create a gitignore file, and I'm going to add node modules to it. And now, if we go back and look, we should see instead of that node modules, we've got the gitignore file, package lock.json, and package.json is modified. And if you're ever unsure what is changed when you've made these sorts of changes, like what have I changed since the last time I committed? You can use the diff tool built into Git. The output won't be the easiest to read the first, I don't know, 20, 30 times you see it, but eventually it'll be something that's pretty easy to parse and understand. And so this negative, that means that line is no longer in there. That line has been removed, but if you look at this plus here, oh, you have this line now. Well, it looks like they're the same. So it's unable to tell you that the line changed. It just says this line's not there anymore. This one's here now. And the only difference really is this comma at the end. And then it added this dev dependency to our package.json. So that shows us what's different right now between what's committed and what we have untracked. So now I can do a git add, and I'm just going to do dot because I know I've got a few files I want to add in. Again, git status. Now I see it saying they're all ready to be committed. They're not untracked. And I can do a git commit add jest dependency. All right. Sort of working through this bit by bit. So now I've got jest installed as a dependency, and it says first create the, well, I'll create the index.js file. Oops, I don't want to go into node modules. Wrong place. Go away. All right, here we go. So I'm going to do my work in index.js here, and then I'm going to write my tests first. So if you remember right, it's test is the default .test.js. So that's sort of our default thing that we can do here. So our first test that we're going to want to write, as usual, and you'll see this stuff get sort of refactored as we go, has us modify our package.json as well. In fact, I'm going to do that in just a moment, and I'll show you another feature of Git that we haven't really talked about, and one of the reasons that it has this concept of unstaged versus staged changes. But right now, let's go ahead, and I'm basically going to steal this, even though I'll change the code a fair bit, because we're not going to require sum, we're going to require index. And our first test should be correct change exists. And let it roll it. So I'm going to call this index, and then I'm going to say, just trying to call index.correctChange, which will probably fail when this runs. But again, it shows us, oh, we need to modify the package JSON and add this test jest bit to it to make it work. Okay, we'll go into our package JSON. Easy enough. Where's our script section? Oh, we already have a test that says no test specified. which if you're unclear what that means, it means if we, in this folder, try to do npm test right now, it's going to tell us that we have no test specified. But we want to replace that with just jest. And now we can run npm test. And we fail because correct change doesn't exist. It's not a function. But let's say we wanted to, I wanted to have this test jest thing. I intended for that to be committed before the other changes, like before I start writing my tests. You know, something simple like that. This is where the idea of this staging area comes in. So if we do get status, again, we can see, the package.json is modified, index.js and index.test.js are all there, but none of them are staged. It says changes not staged and untracked, right? So now if I do git add package.json, keep stuff up at the top here, get status, we see changes to be committed is just package.json. So just the changes to that. So I'll get to that question in a second on Jest. So we just installed or just made the change to package.json and we want to commit that separately. By putting it into our staging area, we can now do that commit separately. Run jest for npm test command. And if we look at our get status, our other files are still sitting here. They haven't been committed yet to Git, which means it doesn't yet know about the changes that we've made to these files, but it does know about the change to package.json. So this is really handy when you're working on a large set of code, a lot of files at the same time, and you want your individual commits to have these meaningful bits of code all as one part of a commit. Maybe you need to do that. So you grab a few of the files, you commit that. It's not something people do all the time. It depends on what your workflow is. But I wanted to do it because I don't want my tests to just be failing. I want to make sure that anytime I'm committing stuff, it's passing. And so I don't need this. I'll leave the README up and get rid of this for now. And let's go to our index.js. And I'm going to create the function correct change. And then I'm going to export it. I think syntax, I may be wrong. We'll be out in just a moment. Let's try this. Oh, all right. I exported it wrong. Is it module.exports.correct change? Let's see if that's correct. If not, I'll have to go look up the documentation. So we'll check it now. Okay, there we go. Got the syntax correct. So we've got this working. We've started our cycle. We're looping through. I'll go back to this other command prompt. And the only reason I'm going back to this one instead of doing everything inside of the one built into Visual Studio Code is just for people who are more comfortable with like Cloud9. I want them to feel like they can work this way on any command prompt. So now I do my get status. I see these files changed. I want those to be in there. So I'm going to commit that. Initial or create, I'll say, correct change function. All right. Get status, everything's fine. Let me look at this question that's up here. So every time we create a file and want to use Jest, we need to install it, or are we just installing it to using GitHub? So it's not, that's a good question. It's not every file, but it's every project you're going to want to install it. And it's installed just in that folder. So if I were to list my files here, it's installed only here in this folder. So anytime you're working on a project and you want to use Jest as your testing library, then you're going to need to install it for that specific project. I hope that answers the question. Feel free to ask again if it wasn't quite what you were asking. All right, now I'm going to sort of accelerate this workflow, move a little faster, and I'm going to do it using the tool that we talked about last time, which is instead of just running the tests once, I'm going to do this watch. So this is going to continue to run every time I add every time I change any of the test files that it's already aware of or the files that those import. It's going to basically rerun all of the tests. So now I'm going to be able to start writing more tests without having to manually run this every time. All right, so if I'm going to go to the README, let's see here. Let me make this look a little nicer. Just looking at the preview instead of that. There we go. You purchase something and pay in cash. Okay, what might be the simplest change version here? If I'm trying to write tests and do just the minimal amount of code, I think maybe the simplest is so let's say it provides no change when the customer provided correct change. All right. This should be pretty simple. And I'm gonna, again, I don't want to type this index dot every time. So I'm actually going to, oh, I did const here. Let me change that to var. We haven't talked about const. It's not a big deal, but I'm gonna say correct change equals index dot correct change, and just change the way I refer to it everywhere. That way it'll just be a little easier. And again, I did this a little different than last time where I was doing like require and then I might do like correct change to get the method. I'm just trying to give you guys different examples of the same code so you can see that it's doing the same thing. It should help solidify how it's actually working. We'll call correct change, and now we need to pass in two different arguments. It's going to need to be able to take some arguments. So let's say it was $1 and we passed in $1 of change, and we expect change to be, I don't know, we'll say it's 0. We may change what we're returning as we do this development, right? Oh, and we fail. And that's because we got back undefined, which is the default of what you get back when you return or when you don't return something. So now I can do this in the simplest way possible. I can actually just return 0 in this code and get my test to pass. And again, I know this sounds silly to do that, but the idea here is you're making the minimal amount of change to get your test passing as opposed to trying to solve everything about it. All right, so let's go ahead. Feeling good about where we're at. This is decent. Let's make some other changes now. So now I want to add another test. Provides 1 cent as change when customer provided paid with 1 cent more than required. All right, so now we have to start figuring out what these different values mean in here. What is this first value going to mean? I guess that'll be the the cost or the total bill or whatever, and the second one will be what the customer paid. So to make this work, we'll say 99 cents, and the customer paid with $1, and so we want the change to be 1. Now it's going to fail. All right, so let's go ahead and go back to our code. And now we need to start doing something. Let's say cost, and let me see if I use certain names in here so I can be consistent. So let's see. I'll just say cost and total, or what is this? I mean, if anyone knows the right term for this, I can't, for some reason, I can't think of what would be the best term for, cash provided. All right. So now I know I need to be able to return, I need to pass both of my tests. So what change can I make to pass both of them? Oh, look, I am testing that's wrong anyways. I really check that I get back 1 penny, not that. Okay, so now I know I want to be able to do this. So I'll just say cash provided minus cost. Oh, I failed. Well, now we run into a really interesting problem that I noticed some of you had to solve with some of your stuff. And this is a little earlier than I expected to see this. I don't know when all the numbers like this happen. So you'll notice it says what you actually received was this long number back that isn't 1 cent. What the heck is going on there? And I think we've talked about this, maybe, I can't remember a tiny bit, but let's test it out real fast. Let's do 1 minus 0.99, and sure enough, that is what JavaScript tells us the result is, which is stunning if you don't understand what's going on. But this has to do with how computers actually represent decimal values, because decimal values are very complex. So computers use something known as floating point notation. There's really, in my mind, no easy way to explain this. I've read a half dozen explanations, if not more, in my time, and I could try and talk to you about what it means, but basically what it means is that for any decimal number, not integers that are whole numbers, but any decimal number, your computer is actually storing basically an approximation, or the closest it can get to storing it, because it only has so much space in one given memory location. And what it does is it tries to spread that out to be able to represent as many of these floating point or decimal numbers as it can. So in this case, it doesn't have a perfect representation for all 3 of these numbers. I don't know which one it is that it can't represent perfectly, whether it's 0.99 or just this result, or 1.00. But it obviously isn't representing everything exactly the way that we would expect. And so now we've got a tough choice to make. We can say, oh, well, what I should do is I should truncate anything after this, so that after a couple decimal places, so that I can do my math correctly and just sort of get rid of anything there. But that could also be wrong slightly. It'd be hard for me to find, again, I don't have these off the top of my head, but there's an example where the answer here could have been 0.99999999999, or I mean, what would it be? It would be 0.009999999999. So it would be really close again, but it could be slightly under. So that's not the best option we have here. So assuming that we're going to have stuff provided this way, maybe I can turn these into integers to work with integer math. And there's several ways to do that. We could still do the rounding, but it's probably a little easier to do this early on in our code. Let's see. This is just something that would probably take a little practice, or maybe even someone else explaining to you. Cost as integer. So I'm going to assume that anything provided to me only has 2 decimal places. And what I'm going to do is do cost times 100. So that will move that up to be an integer. And I can do cash as integer, for example. And I will do cash provided times 100. And now I should have integer values here. So now if I save this, oh, I didn't change any of this. So I need to do my logic with these. Cost as an integer and cash as an integer. All right, let's go back and look at my tests. Oh, we're still failing. Oh, that's because I expected to get back 0.01 and I got back 1. So if I want to here, I could shift this down by a couple decimals, or I can decide I'm going to represent my data that I return back in a different way. So what I'm going to do is, I know that eventually I'm going to want to be able to return nickels and pennies and other stuff as well, right? So maybe I don't want to just return a number. Maybe I want to return, I don't know, an array. And we'll say that the first value in the array represents the number of pennies. Or maybe I don't like that. Maybe it makes more sense to return an object, because that's an easy thing. Because with an array, it would be hard to know. Is that first item pennies? Is it $20 bills? What is it? And if I want to add another cash denomination to it that I can return, it's going to be hard to do that too. So maybe an object makes sense where I can use some named values. So let's go ahead and do that, right? Let's do this. Var pennies equals cash as integer minus cost as integer. And then what I'm going to return here is an object. And the only thing I have right now is pennies. So that's what I will return. All right, so now we're going to be failing both of our tests. Okay, very interesting. So that means, oh, that's because I've changed my values here, right? Now, and remember, this is me knowing that equal versus to be is different. So now I know that in this case, I expect the result to be an object that has pennies with 0. Let's see if we can get that to pass. Oh, looks like that did. All right. So now what about this one? We can change it. We expect it to equal an object with pennies of 1. Let's see. All right, we're passing. So now you can begin to see this cycle, right? This back and forth, going back and forth between the tests and the code. And some of what this tests have helped us do is make sure that our code didn't break while we were writing the tests, and make sure that when we changed something in our code, we had to change all of our tests as well. Okay. So let's go ahead and move on to the next one. Maybe I'll even commit this. I like where I'm at, so I'm going to do a git add these, git commit -m. Returns correct pennies. Right? All right, so now let's add another test. What would be maybe the next simplest test? By the way, while I'm working through these, if you guys want to, I would love to see you posting suggested tests that you think might be the next logical test for us as I'm solving one test. So feel free to post into chat like, oh, this might be the next good test for you to try and solve. because that way I'm not coming up with it all and you're sort of thinking about what's a good thing to test as we move forward. All right, so let's try this. Provides, how do you spell nickel? $0.05 more than required. All right, so feel free to post again the next one after this. Once I've solved this, what do you think is another good test for us to try and write after this? All right, let's see what happens here. So if I'm gonna say the cost is 95 cents, and what I expect is I want a nickel or nickels to be 1. I want 1 nickel. What else do I want? I want no pennies, I guess. All right, let's see what happens here. Ooh. Okay, I passed 3 of my tests. But the third one, this one I'm missing because it says, oh, give back 5 pennies as change, right? Because we haven't done any other logic. So now is our first time to go ahead and go change our code to compute the correct change, what we want for change. All right. Let's see here. So now I've got to do something different. I'm going to say if, let me compute the difference first. Let me just get the difference. Var change equals cash as integer minus cost as integer. So, all right, I know that'll be my change that I want to have. And if my change equals 5, you know, it's sort of getting awkward with creating my object down here. I don't know. And this pennies thing here. So maybe here's what I'm going to do. I'm going to create my I'm going to create my variable here that's going to hold on to this stuff, and then I can just change the properties of it as I'm working through. So let me see here. Change in, we'll call this one change, and we'll call this, instead of change, we'll say that this is just difference between, or let's call this cash difference. I don't know. I'm just choosing names. So we're going to call this change. And what we'll start with, wait a minute, I'm modifying this test right now. That's going to be okay. I'm going to create pennies and say it's 0. And then what I'm going to do is change what I do here and here. I'm going to change this to say, so that all of my tests are passing as they currently are. Instead of assigning this into a variable, I'm just going to say change.pennies equals, and I'll leave it what I had, even though we'll swap that out in just a second. And then what I'm going to return is my change. So let's see what happens when I run this. Now, the good part about this is we still have the same 3 passing tests. So our tests are passing the same way that we were before. So that's really nice and handy for us to have. Instead of, you know, not being sure about this change, did I break something else? I know that all of my tests are passing as I expected right now. But now I also know that I want to change this. Okay, well, I also know that this is just the cash difference right now. Or maybe I'm going to rename this variable in a moment. You'll see me sort of just keep iterating. So now what I can say is if the cash difference is 5, then, oh, I'm going to want some nickels in here. I don't want to return any nickels right now. But if the cash difference is 5, I want to do change.nickels equals 1. And then I need to change this. Yeah, because if I've already given them a nickel, I don't need to give them a penny. All right. Oh, so I need to change what this is. Okay, now I'm going to rename this variable because it makes more sense. So change remaining is what I'm going to call it. It's however much change I need to compute that's remaining. So if it's 5, it's this. And then after that, oh, I also need to change this. Change remaining minus equals 5. See, I took 5 cents off of the change remaining. And then my change.pennies should be whatever's left after that. All right, let's see what we have here now. Ooh, now we have 2 failed and 2 passed. All right, what's going on here? All right. This first one that it says failed provides no change when the customer provided correct change. Oh, because I changed my object, right? Now I need my object to have a little more going on up here. Well, that's a little annoying, but we'll do it for now. We're just going to go ahead and hard code our objects, make them a little more complex. We're going to put them into some variable here. Hard-coded object that says pennies 0 and nickel 0. And then I'm going to expect that here. Oh, that got me passing that test. All right. So what are we failing now? We're failing, 1 cent is changed when customer paid. Oh, look, with 1 cent more than required. Oh, again, it's because I've got this object that I need that has more stuff on it. And now I need to change it to look like this. And I can call this expected. Let's see. Oh, we're passing everything. That's interesting. You notice I didn't have to change this one, although I'm going to go ahead and put this up here the same way so it's got the same syntax. But that's because in my code, I had pre-assigned 0 to everything and then just assigned a different value when, oh, I need to change this. All right. I didn't have to do much there. So it's very simple and easy. And now I'm passing with the nickel. Looking good. Let me see. We have a nickel and a penny as change. All right. Let's give it a go. So I expect to get 1 nickel and 1 penny. Oh. I didn't change this, right? 94. There we go. What's going on? Ooh, I got 1 nickel and 6 pennies. All right, there's something wrong with my code here then. Let's see. Because I'm only checking if I'm equal to 5. Oh, wait. So I got 0 nickels and 6 pennies, right? Because I'm only checking if I'm equal to 5. Well, then I could do this, right? If I'm greater than 5. All right. Oh, greater than or equal to. There we go. Now I've got the right change for a nickel. What about the next one? Anyone have the next test for us? So it looks like we're passing all of our tests. I'm feeling sort of confident here. But I am starting to see how tedious this is going to get, writing all this out, especially if these values change each time. So if I start changing what the starting point is for each one of these, this could get really tedious. So I'm going to introduce you to another concept here really fast, which is, let's see if I can show you this concept of a setup function for testing. And don't worry too much about this. This is just me showing you that we've got some other tools that can make us do something. So here we go. Often while writing tests, you have some setup work that needs to happen before tests run, and you have some finishing work that needs to happen after tests run. If you have some work you need to do repeatedly for many tests, got that. You can use before each and after each. For example, let's say that several tests interact with a database of cities. You have a method initialize city database that must be called before each of these tests, and a method clear city database. All right, so let me look for some examples. All right, let's see if I can. How do I work with this? Before each and after each. Well, we've got an example here. Let's see if I can do it. It just has before each and some code, right? So I'm going to try something out here. We'll see if this works. I'm going to go up here before my tests. Let me, again, leverage this. I'm lazy. So this before each. Well, how do I do something before each? Well, right now I'm assigning this expected in them. Okay, I'm going to instead try and just create this up here. Var expected. And then before each one, I'm going to reset expected to be this object. All right, I expect 0 of everything. Okay, and now I can get rid of it in this one. Let's see if this passes. Oh, it did, but in this one, we need to set our pennies to something, right? Well, that's easy. If I'm changing this, what's going to be happening here, it's sort of interesting. It's recreating that object each time. And since it's setting all of my other values to 0 for my object, I only need to change the ones that I care about for this given test. So that makes these a little bit easier each time, where I can now, instead of having to create the whole object every time, just do the little bit that needs to change. In this case, I expect 1 penny, and I expect 1 nickel. Let's see, and we're passing. All right. So again, we could always go back here, look at our code, and if I want to see what all I've changed, I've changed a lot of code since my last bit. So now I can do like a add all of this. Compute nickel change, right? All right, and only because I'm in a good state, because I like where I'm at. So now I saw a dime, right? Let's go ahead and do a dime, and let's see if somebody else wants to propose the next test after a dime. What might be another good test after we do a dime? So I'm going to go ahead and steal this guy, as usual. Provide a dime. Has changed when customer paid with 10 cents more than required. And because I don't want all these to be the exact same, I want to change the amounts here to make sure that I'm working with different amounts. I know this. I know I don't want nickels, but I do want dimes to be 1. Ooh, I've got all sorts of problems now. So I'm failing one test, this last one, and it says dimes, I expected dimes 1, nickels 0, pennies 0. I got nickels 1, pennies 5.00000014. Got another one of these awkward numbers. We may end up having to do some more work to get rid of these numbers. But let's see if we can at least get dimes in here first. So one of the first things I'll do is, okay, now I need to change what I'm returning, and I'm going to add dimes. 0. Now all of my other tests are failing, and that's because I need them to expect to get back dimes. All right, now I'm back to passing, except for my new test. And now I can just add in some other logic. Okay, well, I already have logic for nickels. Why not do the same thing for dimes here? Change remaining is greater than 10. Change that dimes equals 1. Change remaining is less than or equal to 10. Say, pennies is this ugly number. All right. So now we begin to get in this situation, and there's not going to be a perfect solution to this, I don't think. There's probably some tool out there that'll help me out if I really want to. But we've got this awkward bit about the exact amount, and the pennies are a little off here because it's got this tiny amount left. Let me see what exists in this math library that might help us out. I don't know if there's anything. Math truncate, maybe? Returns the integer part of a number by removing any fractional digits. But what's going to happen if I don't know if that will always do what I want. Or not. Maybe round will work for us. So maybe all we have to do is round. So I'm just going to try that. Try and round out what we have remaining. Oh, math.round. Silly me. Let's see. Oh, that looks like we got it passing. All right. Good to go. So what about the next amount? Anyone have a good suggestion for our next one? Let's try 16 cents. That captures a little bit of everything, right? So if they paid with $1.16, we expect dimes. I expect nickels to be 1. And I expect pennies to be 1. Oh, sweet, we're working. All right, let's go with 20 cents. Let's try that. So I'd expect 2 dimes with 20 cents. All right. Everything else to be 0. Oh, we failed. It says 1 dime, 1 nickel, 1 penny is what we got back. All right. So again, while I'm working this one, think of what our next test should be after this. Oh, and that's just because we only check for 1 dime and we're only putting 1 in there. And I guess that works for a nickel because by the time you have 2 nickels, you can always give back a dime as change, right? But with a dime, 2 dimes is still 20 cents. You're not to the next denomination, which is a quarter yet. So we need a different bit of logic here instead of what we have. All right. So what could we say? Well, we could figure out how many can go into how many of 10 we have. That might work well. So what do we have as our options there? Let me see if this will show it. Remainder operator returns the remainder left over when 1 operand is divided by a second. Well, that's not what I want. Maybe I've got something else that works for me. Go back to my math library, I don't know. Well, I've got this truncate where I've got floor, which just drops the anything after. So it just gives you the integer value. Okay, so I can make this work. If change remaining is greater than 10, change dot dimes equals, let me see here. Change remaining divided by 10, the floor of that, so math dot floor. That should give me however many dimes we were able to get. And then our change remaining is going to be equal to the existing change remaining mod change dot dime. So how many dimes we got out of it? Or, oh no, not dime, mod 10, right? Because that'll give us how much is left after 10. Let's see if that works. Oh, no, we still have something wrong. All right. How is truncate different than number.toFixed method? That's a good question. Well, you get to see some of it here. It says toFixed returns a string representation of the number object that does not use exponential notation and has exact digits after the decimal place. The number is rounded if necessary, and the fractional part is padded with zeros. So one difference is you get back a string, whereas with truncate, you should get back a number. But obviously, I'm doing something wrong here, right? This is math.floor. So let me check this. I'm just going to swing over here real fast, pull up the terminal, do some testing. So if I had 20, divided by 10, I get back 2. All right. Math.floor of 20 divided by 10 should give me back 2. And then what would 20 mod 10 give me? It should give me 0, right? Okay. Interesting. So why am I still getting back this information? If change remaining is greater than or equal to 5, let me double check and just make sure. I'm going to run all my tests. Oh, sure enough, it's still failing. Let me come over here and check. Ah, I didn't change my value here. Look at that. My test was wrong all along. All right. So I'm going to speed this up a little bit now because, sort of moved through it, but you're going to begin to see how I changed the code on the fly too. And this is one of the great things, again, about test-driven development is when you have all these tests in place that are already computing things, you're going to be able to refactor your code with a high level of confidence that you won't break it. So let me do the next one. Next one, let's try 24 cents. Provides 2 dimes and 4 pennies. It's changed when customer paid with 24 cents more than required, and I'll just make this 24 cents more. I expect my pennies to be 4. Let's see. Oh, sure enough, we pass. So now let's jump up to the next one, which will be a quarter. $0.25 more than required. Again, let me change these values a little bit just so I'm not always using the same values. So I'll do 1975 and the customer paid with 20. I expect quarters to be 1 and everything else to be 0. Oh, there are no quarters. I haven't added it yet. So I need to add that to my object here. And now we're failing all of our tests again because I need to go up here and add in a quarters to my object that I'm expecting. All right, all my other tests are passing again, and now I just need to add the quarter logic. So I'll go ahead and add that in. Again, we're going to cut and paste this, at least to start. If change remaining is greater than 25, then we want to divide by 25, and we want to take whatever's left and have a mod from 25. Let's see what happens. Oh, I'm setting this to dimes. Let's try quarters. All right, so we pass. So now let's try another value somewhere in between here. Oh. I can do, oops. Copy this guy. Dang it. Keep messing stuff up here. All right, there we go. Provides a quarter, 2 dimes, and 4 pennies. It's changed when customer paid with 49 cents more than required. So now I'll drop this down. We'll do 1951. They paid with 20. Let's see. Oh, I didn't change my expecteds. Dimes equals 2. Expected dot pennies equals 4. Oh, and we are passing. So we've got a lot of cool tests running now. And again, you're thinking, well, there's not a lot of code here. It's a little silly, but now we can do some pretty significant changes to this logic that might make this a lot easier to work with or to expand as we keep growing. So now if we start looking at this, we begin to see a pattern, right? Oh, everything sort of has this same pattern. The change in one amount is the floor of dividing by that amount, and then the change remaining after that is the modulus operator after that. And it's the same for nickels or dimes. And actually, it's the same for nickels, even if we didn't write it that way. So if I were to change this and say math.floor change remaining divided by 5, and now I'm going to change this to say change remaining equals change remaining mod 5. Let's see. All of our tests pass. And so we've gotten ourselves to a point where all of this logic is the same. It's nice and easy. In fact, we could even do it with pennies. The difference is, any integer mod 1 is going to be 0 because it goes into 1 effectively. So I'm going to, as weird as it seems right now, change my pennies to read the same way. And we will say change.pennies equals math.for change remaining divided by 1. Let's see if that works. It might fail because of the hold on, let me see here. 3. Yeah, it might actually fail because of rounding. So I'm going to leave it the same as it was, just for the sake of not struggling with those rounding issues. But now we can, before we do any more, we can take a look at this and say, okay, we've got a consistent pattern in code. Can I rewrite this code now in an easier way? And sure enough, I could definitely rewrite this in a simpler fashion. So what if I know how much each amount is, I'm going to create an array of amounts. And let me see how I'll do this. Maybe I won't. Maybe I'll split this stuff out. This stuff begins to look almost like a function that we're calling, potentially. So, trying to think about how I'm going to make this so that I'm not just repeating stuff here. There's several different ways I could refactor this. Okay, yeah, I'm just going to split this out into a function that we'll be able to call internally. So I'm going to make a function. And remaining. I'm going to say total and amount is what I'll take in here. So the total is my change type value from before, and amount is whatever amount I want, right? So if I were to look at that, then what I can say is, oh, for this, like, amount would be 25. The total is what I'm passing in. So I'm going to need to compute two things out of this, right? I need to compute var change in amount, if you will, which is just going to be this math.floor logic, except instead of this, I'll use amount. And then I'm going to say var remaining equals, oh, this isn't change remaining, this is total. Total mod the amount. And now I need to return both of those. Now there's a lot of ways to do this. I'm just going to return an array. It's just, I know what it's going to give me back. So I'm going to say change in amount and remaining. You know what? I'm going to change that because I think it's a little clearer if I return an object. So change in amount is the change in the amount, and remaining is just remaining. All right. So I've got a function up there, but I'm not calling it anywhere, right? So maybe I can change one of these bits of logic to use it. So what if I change this 25-cent one, this quarter one, to just say, instead of all of this, I'm going to get back var quarters equals change in amount and remaining of the change remaining so far. Oops. And then 25, because I know that's what I want. I don't even need this now. Oops. Let me come up here. And then I know change.quarters, I want that to be the floor. You know what? I have that floor logic up there. I made that. So I want that to be the first, or the quarters dot change in amount. And I want my change remaining to be quarters dot remaining. And let's see if this works. All right, now we've sort of cleaned this up a little bit. And we could make this even cleaner if we want to. But we've made it a little easier to do this logic. We've taken this repetitive if and other stuff out, and maybe we can just replace it with something like this, right? So now I'm just gonna take this guy, replace it here. Instead of quarters, I'll do this. I'll call this dimes. Let's see if it works. Sure enough, I can do that same thing. Take this logic, put it here. I want this to be 5 cents. Instead of dimes, I can say nickels. Let's see. Then you begin to see the value of these tests, right? I just changed a whole bunch of code really quickly, and I knew that it was passing. Whereas if I had screwed something up, like I put 4 here, oh, something's failing. Or if I had screwed up my function up above, it would have told me right away that something was wrong, right? So now I can go ahead and easily add in the remainder of these computations. Let's see what else we said here. Said quarters, $1, $5, $20. All right. This should be pretty easy to add in. Test, provide $1 is changed when customer paid with 100 cents more than required. So let's say it was 19, they paid with a 20. So I expect dollars to be 1, nothing else. Sure enough, I'm going to fail. Oh, yes, I don't have dollars anywhere, so I'm just going to add it up here. And then add it over here. And then now I only have the 1 failure, and I can just take this bit of quarters logic and put it right up here instead. Make this dollars. Say $1 is 100. And we're passing. And it's just as easy to add in the $5 and $20 tests as well. It should take no more work. So if this is like 1450, let's do a nice round number. Yeah, we'll just do 15. It's fine. And the customer paid with 20. Then I expect 5s to be 1. Oops, not that. Go all the way up here. Add in 5s. Add it in over here. Copy this bit of logic. And we'll say 500 there. Let's see. Awesome. So let's add another one around that. Very similar. Let's try and do the next amount right before 20. So that would be provides a 5 for 1s. 3/4, 2 dimes, and 4 pennies. So 5, 6, 7, 8, 9. When customer paid with, now what would they have paid with? Let's see. So this would be if the total was like 1001, I guess. So they would have paid with, that right? I don't know. We'll find out. See if that works. Huh? Something's wrong. Oh yes, I didn't change my values here. Expected dollars. Oh, I could change that to ones maybe. Maybe it makes more sense. I don't know, but quarters to be 3, dimes to be 2, and pennies to be 4. Let's see. Awesome. Passing. And so now, I mean, I feel quite confident it's easy for us to add the 20 as well, right? So that's going to look a lot like this. I'm going to copy this one instead of the one farther down. Should be nice and easy to add. So let's see, their total was like 21 and they paid with, or no, let's go with their total is 30 and they paid with a 50, right? So I expect 20s to be 1. Of course, we're going to fail because we don't have 20s. So we'll add it to our object up here that's getting recreated each time. We'll add it in here. And we're going to take this logic and copy it. And this is 2000. Let's see. Awesome. Looks like we're passing. All right. And we could, again, there is a lot of refactoring that could be done to make this code simpler than what we have right now. So if we take a look at this, there's still a lot of repetition here that we could probably pull out in different ways. There's a lot of things we could do to make that easier to work with. You know, if we just used an array, we might be able to consolidate it more. Or maybe just some other variables. Maybe we stored these values in some way so we could loop over them instead of having to write them out one by one. There's a lot of options here to make this much more concise than even what we have now. But if we do that, we'll be doing it with a high level of confidence that we're not breaking it. So I think that's probably what I'm going to encourage you guys to work on if you want after this. Following this class is going to add these in. And I'm going to push this up. And then I'll post a link to it. So what I would encourage you guys to do if you want is to feel free to take this and fork it up here on GitHub and to try refactoring this code so that it's a little more concise than what we have here. Whether that's using an array and putting stuff in an array in some way, or whether that's some other smart method or approach to doing this. Try and take all of this logic and the tests and make it a little more concise, a little more consolidated so that, you know, we wouldn't have had to write it out this way each time. But while you're doing that, run those tests in the background. If you're unsure, the command you need to run when you're working on it from inside of the folder, first you're going to need to run npm install after you pull it down, that's going to install Jest and all the other dependencies. And after that, you can run npm test -- watch if you want. That will keep the test runner running in the background. Or if you just want to run it once, you can just do npm test, and that will run it just once to see how stuff's going. But I encourage people to pull this bit of code down and try and make it more concise. If you haven't already worked on correct change, or if you have your own version of this, try doing that. Or try writing tests against your version of the correct change, whether it's a string or something else, so that you can try refactoring it pretty smoothly and fluidly. Yeah, I mean, I hope that was useful, again, trying to work through every little piece of this process and show you a little more test-driven development and some of the benefits you get from taking that approach. If anybody has any other questions tonight, let me know. Otherwise, I think we're going to end it for tonight, and I will see you guys Thursday in person at the American Underground. Looking forward to seeing you.